So we've already looked into a little bit of factoring trinomials in section 8.5. In section 8.6, we're going a little bit further in factoring different sorts of trinomials. And that would be ax squared plus bx plus c. That basically means we're going to have a coefficient in front as well as coefficient for the last and a constant. So again, we can write some trinomials of this form, ax squared plus bx plus c, as the product of two binomials. So that's when they're asking for it in factored form. And the difference in this section, if we consider this trinomial 6x squared plus 23x plus 7, in the last section we didn't have any examples that started with like that 6 in front. So first of all, let's just think of this 23x in the middle as 21x plus 2x. So if I take that trinomial and rewrite the 23x as 21x plus 2x, the way that we're going to factor these is we're going to look at GCF of the first half. We're also going to look at a GCF of the second half and see if we can factor that out. So in the first half, that 6x squared plus 21x, from both of those, I can factor out a 3, because 3 goes into 6, 3 also goes into 21. Also, since they both have an x term, I could factor out an x as well. So 3x is the GCF of those first two, my greatest common factor. And that means that when I factor out 3x from the first two terms, I'm left with 2x plus 7. Again, if I take the first term, 6x squared, divide out the 3x, I'm left with 2x. If I take 21x and divide out 3x, I'm left with 7. So we have that first part factored. Second part, there actually is no common factor other than 1. So if there's no GCF other than 1, I can just list 1 as a GCF and rewrite that second part, 2x plus 7, the same way. And now that when I put these pieces together, we're going to get our factored form. If I look outside my parentheses, I have a 3x and a plus 1, so I'm going to put that together as a factor. My other factor is just going to be the 2x plus 7 that I see appears in both of those parentheses. So you should always see that. The way this is going to work is that when I factor my GCF out, so factor out the 3x, factor out the 1, the two parentheses that I'm left with should always be the same, and that's where I get my second factor from. So let's go back into why we did that first step in the first place. How did we know to rewrite 23x as 2x plus 21x? How do we know that we weren't writing it some other way? We have to notice that if I multiply 2 and 21, the coefficients I was getting from that last example, that gave us 42, which is the product of the x squared coefficient 6 and the constant term 7. So last time when we were looking at factoring before, we were only looking at the last number to find out what to multiply to. Now that I have a number in front, I'm going to multiply together the first and the last number. So 6 times 7 gave us 42. And we also want to choose 2 and 21 because that adds up to 23. So in general, if we want to factor ax squared plus bx plus c, I need to look for numbers that multiply to give you ac and add up to give you b. And that's going to be a little bit, probably make a little bit more sense if we look at this example. So if I try to factor, again, if I have a leading coefficient, this time I have a leading coefficient of 6, so we wouldn't have seen this problem in section 8.5. Now if I'm trying to put this in factored form, again, the first thing you want to do is I want to look for numbers that multiply to give me the first and last number as a product. So 6 times 5, that would give me 30. So I want numbers that will multiply to give me 30 and add to give me that middle coefficient, that 13x in the middle. So just like what we did in the last section, now that I know that I have to multiply to get 30 and add to get 13, two numbers that will work for that are 10 and 3, because 10 times 3 gives us 30. And also 10 plus 3 gives us 13. Now that I know that my two numbers are 10 and 3, I'm going to rewrite that middle term that used to be a 13x. I'm just going to break that into the 10 and the 3. So the first and last term should still be the same, still start with 6x squared, still finish with 5. But that means just like in our last example, I want to see if I could factor a GCF from the first two and factor a GCF from the last two. So if I'm trying to factor those, it looks like from the first two terms, I could take out a 2, and I could also take out an x. So my GCF would be 2x, and when I factor that out of the first two, I'm left with a 3x and a 5. Looking to my second two terms, I also don't have any common factors other than 1, so we can just leave 1 there as a placeholder, and we have that same 3x plus 5. And just like in our last example, the two parts outside the parentheses I'm going to combine. So 2x plus 1, that's going to be one of my factors. And my other factor is the two matching parentheses. That's just going to be 3x plus 5. So again, if I FOILed this back out, we should see that it get us back to that original question. So factored form here is the same as what we saw in that last section. Only difference is that we're doing a little bit different multiplication. So let's say if I start off with just any general trinomial again, ax squared plus bx plus c, and let's say if we have a positive product, so if I did 6 times 5, that was positive, but let's say if that middle term was negative, so let's say if we had like a negative 13. What we know about the factors of AC is that those would both have to be negative. So this is pretty much what we saw before. If you have a minus and then a plus, that means you need to multiply together two negatives to get a positive. We also need to add together those same two negatives to get a negative for the middle. So whenever we see that, whenever it's minus and then plus, your two factors are both going to be negative. So if we're trying to use this also with some more examples on the back, walking through our same steps, we just look like we have a little bit more complex examples. So 10x squared plus 31x minus 14, got to put that into factored form. So first step, we want to see what number we have to multiply to get, and that's by taking the first and last numbers together. So 10 times negative 14 gives us negative 140. So we're looking for our two numbers that will multiply to give us that, negative 140. We also want to add those two numbers together to get the middle, which is 31. So some of these might be harder to think of factors for. You can always do some work off to the side. 1 times 140 makes 140. 2 times 70 makes 140. But what we're looking for is 4 times 35, because if I find a difference between those, that gives me a difference of 31. Remember, one of those has to be negative, one has to be positive, because I want a multiply to get negative and add to get a positive. So if I make the 4 a negative and the 35 a positive, that way I can multiply those together and get negative 140, and add those together and get a positive 31 instead of a negative 31. So if I'm putting those into my factored form, that means instead of that middle term being a 31x, I've just broken that up into a negative 4x and a 35x. That's where I'm using those two numbers. And now that I have the first and the last terms the same as they started, this is where I'm looking for GCFs. Again, look for a GCF of the first two. Also look for a GCF of the second two. And of my first two terms, it looks like I can factor out a 2, and I can also factor out an x. So if I factor out 2x as my greatest common factor, I'm left with 5x and minus 2. Same thing on my next pair. If I can factor out a 7 from both of those, and I can't factor any x's, I can factor out a 7. That leaves me with 5x and another minus 2. And again, if we did that step correctly, we should see that the parentheses match from the first group and the second group. So for my final answer, our last step is just to combine the outside parts, so 2x plus 7, combining those as a factor. My second factor is just going to be those parentheses, so 5x minus 2, that's my other factor. Let's work through that again, but just kind of asked a different way. So you might be asked questions about area of a rectangle, and since area of a rectangle is just length times width, that still means we're just looking for basically this trinomial put into factored form. So if I'm trying to look for dimensions for length and width, that means if I'm looking for my factors, first thing I want to do is multiply the first number and last number. 8 times 15 should give me 120, so I'm looking for two numbers that will multiply to give me 120 and still add to give me 22 from the middle. And those two numbers end up being 10 and 12. If I multiply those two, I get 120. If I add 10 and 12, I also get 22, which is in the middle. Remember, you're using those two numbers to rewrite your trinomial. Instead of that middle 22, I'm going to break that up into a 10 and a 12. Actually, it doesn't even matter what order you put those in, so if you put 12x plus 10x, you'll still end up with the right answer. But after I have that rewritten, I'm looking for my factors, my greatest common factor. So if I factor out a 2 and an x from the first two terms, I'm left with 4x plus 5. And for my second two terms, I can factor out a 3. That leaves me with also 4x plus 5. So again, we can check and see that we did that step correctly, since both of those parentheses parts should be the same. And for my final answer, I'm just going to combine the outside parts as one factor, 2x plus 3, that makes one factor, and your parentheses will be the other, so 4x plus 5. And for some of these questions, you also might start with some big numbers to begin with. So if I want to factor a polynomial completely, first we can always check for a GCF of the polynomial's term. So we can always see if there's a GCF that can be factored out first. Then we factor the remaining polynomial until it's written as a product of polynomials that can't be factored further. So basically we're just looking for our same factored form as before. So the only difference here, if we look at our next example, if I'm trying to factor 8x squared minus 36x minus 20, there is a common factor for all of those terms at the very beginning. So I could factor out a 4. 4 goes into 8, 4 goes into 36, 4 goes into 20, and then I'm left with a simpler trinomial. So that's always a step you want to look for first. If there's a number that goes into everything, take that out first. that'll simplify your trinomial. So after we factored out the 4, we're left with 2x squared minus 9x minus 5. So if we're following our steps, again, the number you want to multiply to is first times last. So 2 times negative 5 is negative 10. We also want to add those two terms together to get our middle term, so negative 9. And the two numbers that should work for that, so negative 10 times 1 is negative 10, and also negative 10 plus 1 is negative 9. So two factors we're looking for are negative 10 and 1. And again, the only difference here is that now we're going to break that trinomial apart. So the negative 10 and the positive 1, we're using that to rewrite instead of negative 9. And same steps from this point. If I have my 4 terms, I'm looking to factor out the first two and factor out the last two. So I can factor out 2x from my first two terms, and I'm left with x minus 5. In my second two terms, there's no really common factors, so I can just leave a 1 there and just leave that as x minus 5. Again, we can tell that we did it correctly because I have x minus 5 as the same parentheses for both. So if I'm writing that in my final answer as factored form, we do have to remember that there was a 4 factored out in the beginning. So the 4 is still going to stay in front, but for the rest of my factored form, we found that using the same steps as before. 2x plus 1, the outside parts are going to make one factor. X minus 5, that same parenthesis is going to make your other factor. So just make sure to factor out the 4 at the very beginning. That allows us to do the same steps for the rest. Make sure you have these notes completed and also answer the questions to get credit for that video.